Details of how a runway is constructed, and how the progress, safety, and quality will be monitored and controlled. Also the measures to ensure that the site is environmentally friendly. The purpose of this video presentation is to give an understanding of the methods, plant, and sequence to construct a runway. Work sequence and methods. 3D animation of the construction operations and plant. Used to give an overview of the construction process. Earthworks. Muck shifting is the process of moving large quantities of soil and rock. Earthworks include excavations, trenching, haulage, backfilling, filling and compaction. Crushed aggregate base course. The crushed aggregate base course is produced by the accurate proportioning and blending of 4 aggregate sizes and water using an aggregate stabilizer batching plant. After verification that the finished subbase layer is within the specified tolerances, the surveyors establish string lines with support pins at 10 meters centers. The mixed aggregate base course is delivered by tipper trucks to the job site and tipped into the paver's hopper. Generally 6 to 7 trucks are required. The material is applied in layers not exceeding 150 mm compacted thickness. The aggregate base course is spread using tracked pavers fitted with automatic screed control to the required width, thickness, profile, camber, and crossfall. Asphalt paving. Prime coat site trial. Prior to starting paving, all the materials are pre-tested and a site trial is carried out to familiarize the crew with the equipment and the characteristics of the particular asphalt mix and to ensure that the workmanship, as well as the material, complies with the specification requirements. The polymer modified bitumen asphalt mix is laid with 2 tracked pavers equipped with extending screed, tamper and vibrators, auger, and conveyor, working in echelon in a staggered formation producing a 15-meter wide mat. Level control is maintained by 2 string lines as a grade reference system for the lead paver and a matching shoe and 1 string line for the following paver. The pavers operate using an automatic screed control, which controls the screed height using the string line or the matching shoe as a level reference. The uncompacted asphalt level behind the paver is checked by pulling a string line between the longitudinal string lines at the 10-meter Schenage pin locations and taking dip measurements using a tape measure. The asphalt after compaction reduces in thickness by approximately 20%. The jointing and laying sequence across the runway is designed to ensure that the longitudinal joints are staggered by 300 mm between layers. Free edges that will form joints are cut back by 100 mm. The level tolerance is +/6 mm and the smoothness tolerance is a maximum of 6 mm with a 3-meter long straight edge. Average output is 4 to 5 loads per hour, that is equal to 120 tons per hour. Pavement marking. Pavement marking to runway using an emulsion paint. Pavement cleaning. High-pressure spinning water jets are used to remove rubber from runways that builds up as a result of planes landing. Testing for skid resistance. Using the Douglas mu-meter continuous friction measuring equipment. Test for smoothness. Using a rolling straight edge. Test for texture. Using the sand patch test. Airfield ground lights. Construction methods and details. Ducts are placed in the crushed aggregate base course. Holes are cored through the asphalt for the runway and taxiway centerline inset lights. A jig is used to position and level the light spots prior to grouting. The lights are used at night and in poor visibility to guide the aircrafts. Airfield ground lighting control and monitoring system is used to control and monitor the airfield ground lighting equipment installed for the efficient and safe maneuvering of all ground traffic. Localizer provides lateral radio guidance to an aircraft approaching and landing on a runway. Approach lights used by the pilot to align the aircraft visually with the runway centerline. Glide path provides radio vertical guidance to an aircraft approaching and landing on a runway. DVOR ground station. Omnidirectional radio range. Electrical substation. Contains switchgear, protection, and control equipment. Taxi guidance signs. Concrete paving. Horizontal slip forming for concrete pavement. The process consists of placing and spreading low slump concrete on the ground in front of a paver that slips over the concrete and extrudes strips of slabs. Vibrators fixed along the front of the paver consolidate and fluidize the concrete. The concrete is then shaped by passing between the vertical side forms and underside of the horizontal profile pan as the paver moves forward. Finally, the top surface is brushed to provide a texture, and curing agent is sprayed to the top and side surfaces. Concrete strips of slabs, also known as lanes, are paved to a hit and miss lane pattern. The hit lanes, also known as pilot lanes, were slip-formed first with the infill lanes completed later after a minimum of 14 days to avoid damaging the pilot lane concrete. Timber stop ends are used at the start and finish of the lanes and where the operation stopped unexpectedly. At expansion joints along the lanes, it isn't possible to insert dowels and expansion filler board with the slip form process, so a slab was left out that was hand laid at a later date. Stop ends for transverse joints had to be made smaller than the slab profile to allow the paver to move over without dragging the stop end, therefore the stop ends were set 500 mm from the required locations and the concrete was cut at the required location. This is known as cut-back construction. Slabs containing inserts were identified beforehand and left out to be infilled later by handwork. Milling/planing machine. Milling machine in use. Cable laying. A winch is used to pull the cable of a drum. Rollers are used so the cable doesn't drag along the ground. Horizontal directional drilling is a trenchless method of installing underground pipe, duct, or cable using a surface-launched drilling rig, with minimal impact on the surrounding area. Fencing. Methods and plant and work sequence. Operational restrictions. Some of the restrictions for working near live runways. Photographic examples of airside working. Article on runway pavement. Click link to read. Pavement construction. Details of asphalt and concrete mixes. Flight check. Aircraft performing flight checks on new instrument landing system. Concrete wall construction. The sequence to construct a reinforced concrete wall is as follows. Tie the reinforcement. Erect stop ends and the wall shutters. Pour and vibrate the concrete mix. Remove the shutters after the concrete has hardened. Culvert and head walls. Sequence to construct a culvert with head walls. Oil interceptor. Construction details. Pump station. Excavation using well points dewatering system. Dewatering. Dewatering is the removal or drainage of groundwater and or surface/rainwater, usually by pumping to keep the works dry. Fencing. Examples of temporary fencing. Hoarding. Examples of site hoarding. Wheel Washington, used to wash the wheels of trucks prior to leaving site. Electricity and lighting. Examples of floodlights. Welfare facilities. Includes toilets, washing facilities, canteen. Asphalt batching yard. The main batching plant has a production of 300 tons per hour. The mixing temperature is 165 degrees Celsius. The mixer capacity is 3.5 tons. A hot mix storage silo has a capacity of 125 tons. Concrete batching plant. Concrete batching plant comprises concrete mixer, control cabin, silos for cement and fly ash, aggregate bins, and conveyor belt system to feed the mixer. Crushed aggregate batching. Different sizes of aggregates are mixed with water in a continuous mixer. The mixed material is transported to a discharge hopper by conveyor belt. Quarry and aggregate production. Rock is blasted free from a quarry face and fragmented. Safety and environmental. Emergency telephone numbers and response plan. Dashboard for monitoring and reporting health and safety issues. Site posters. Safety precautions. Excavation safety. Existing underground utilities and overhead cables, safety measures. Before digging, ascertain the location and route of existing underground utilities from the utility companies and by opening manholes and chambers, and using utility tracing locators. Mark the route of underground services on the pavement with the depth and diameter, using the standard utility color code. When working near or crossing under overhead electrical cables, erect barriers parallel to overhead cables and goal posts for crossing under the cables. (3D) animation showing trenching safety measures. Environmental measures. Segregation of waste. To aid recycling and ensure hazardous waste is properly treated. Dashboard for monitoring and reporting progress. Histograms. Shows resources etc. for each month of a project. Resources, plant and manpower list. Daily work record. Records the allocation of resources, materials, and work activities carried out daily. Organogram. Shown are the line and lateral relationships between the various team members and their relative position in the site organization. Staff directory. Quality assurance. Dashboard for monitoring and reporting quality assurance issues. Tests, to ensure materials and workmanship are in compliance with the specification. Surveying and setting out. Methods and checks. Program. Gantt charts are used to plan and schedule projects. Miscellaneous. Terminal building. The roof trusses are a maximum of 190 ton in weight. Shipped in prefabricated sections, welded together on trestles and lifted into position. Mock-up of roof construction. Structural steel to the piers. Pedestrian boarding bridges and bridge houses. Pier construction photographs at various time stages. Roof covering. The top sheet is rolled into shape on site and cut to length. The top sheet has a standing seam. View from air traffic control tower, down onto the terminal building under construction. Air traffic control tower. Constructed using a jump-up shutters system.